All right, so 5.2, solving quadratics. So in this section, we are going to learn multiple ways to solve quadratic equations when they're set equal to a number. The number particularly being 0, okay? Because of the zero product property, it's unique to 0. We like 0. We're going to solve these graphically to begin with, but we're going to also then solve them by extracting square roots. We're going to solve them by factoring. And then last but not least, we're going to solve them by, we can solve them even by completing the square. We can solve them also by the quadratic formula, which y'all remember from Algebra 1, right? So much fun. Yeah. All right. Now, these things right here are all the same. When you solve the quadratic equation, y equals 0, you're going to want to add something here. Solve the quadratic equation. No, it's not. It's in my iPad was not wasn't synced up. Let's try this. Solve the equation y equals 0. Yeah, there you go. I just had to resync my pen for some reason. They're the solutions to the equation y equals 0. It's really the same thing. You don't really solve a quadratic until it's equal to a number. So you're going to be asked to solve when it's equal to 0, or after you set it equal to 0. The roots of the function and the zeros of the function and the x-intercepts of the function, these are all the same. All of these are the same thing. Okay? I tend to call them roots just because that's what I learned. Zeros is very intuitive because it's where the y value is 0. And that's where the graph crosses the x-axis, so they're x-intercepts. X-intercepts are really, really useful when you're trying to sketch a graph of something. Otherwise, I'd go with roots. Okay? So, what can possibly happen? You can have, if you're looking at how many solutions this could be like 0 real solutions. 0 real solutions. Okay? Because there's no intersection point. What if it bounces off the axis? Boing, this is a bounce right here. It's just one, right? There's one real solution. And over here, if it is a cross, we call this a cross, it just crosses straight across, then there's 2 real solutions. 2 real solutions. And we know that we can also find imaginary solutions or complex solutions when we encounter an equation that has a negative under a square root. Okay, that's a possibility. All right, so to solve graphically, I'm just going to make my own rules up, okay? I'm not going to really listen to those. I'm just going to take you through one of them. Example 1, f of x equals that. The instruction says to solve. I don't really like when it just says to solve and it gives you a quadratic. There's nothing to solve here, right? It's f of x equals. That's what it is. It's a name equation. You don't solve a name equation. You are your name. It only becomes an equation once you set it equal to 0. But that's what the instructions are intending you to do. So just keep that in mind. X squared plus 5x minus 14 equals 0. Okay, now once it's equal to 0, you look to see if there's 2 variable terms or 1 variable term. How many different variable terms do we have? 2, okay? So we're not going to bring things across and separate or isolate the variable. Secondly, can we factor it? Well, we probably can factor it. And if we can't factor it, we can always use the quadratic formula. But there's another way that we can do it that we're going to learn right now, and it's called graphing. And here's what I'm going to teach you to do. You're going to graph this in y1. You're going to graph this in y2. Bless you. So if we were going through the steps so far would be this. Number 1, get it equal to 0. Get it equal to 0. Number 2, put f of x in y1 and 0 in y2. So let me go ahead and catch up with what I'm writing here. Bring my calculator up. Hopefully it's still there. Yep. All right, so let's do that. Y equals, I'm going to clear out what I have in there, and I get x squared plus 5x minus 14. I hope you're doing this at home, Chase, and I hope your temperature is down. Chase Onan is at home with a 104 fever, apparently. So, anyway, I know he's watching the videos. This problem goes out to you, Chase. Yeah, I'm recording. Yeah. All right, now, here's what you want to do. Once you graph them, you're going to hit the commands zoom 6. Zoom 6. That puts you in a negative 10 to 10 viewing window. So don't hit graph, hit zoom 6. And more than likely, your x-intercepts are going to be seen in this window. Do you see your x-intercepts? Yeah, there's one on the left and there's one just to the right of the y-axis. Here's how we're going to find them. We're not going to do the 0 command. Nuh-uh. We're going to do second trace number 5. Second trace number 5. And because you graphed 0 in Y2, it'll ask you for your first curve, you hit enter. Second curve, hit enter. And then all you have to do is be close to one of the x-intercepts. I'm closer to the one on the right now, so might as well hit enter. Boom. I don't care. And here I get x equals 2, comma, and then do it again. Second trace, number 5, enter, enter. But now for your guess, you have to either scroll until you're past the midway between them, closer to it, or you can just type in a number that's over there. I'm closer, I'll hit enter. And you get negative 7. And that's it, that's all we're doing. Now, if you don't graph 0 in Y2, and you try doing second trace number 5 intersection, it's not going to work. Okay? But it's the quicker, faster way, because you can just hit enter, enter, enter. And that's what we do in calculus. All right? And that's where I hope to see all of y'all. It's not. Did you graph 0 in Y2? Yeah, in Y2? No, that it has to be there. Yeah.
So do I just put equals
Just put 0, yeah.
Oh, just 0?
Every time, yeah. And that's why I couldn't find the second curve. Now it'll find it. See, now it's there in red.
Oh, so I don't have to do the second.
Yeah, you do second trace number 5. And now hit enter, enter, and then you're closer to this one, so hit enter and it'll find it. Just hit enter. And there it is.
Oh, okay.
And then you can do it again, but this time you have to scroll or type in a number. Any other questions about typing in the calculator? You're learning keystrokes. Yeah, keystrokes. Okay, so I'm going to let you try B on your own, but I'm going to get you started first. On the first one, it was already pretty much, well, it was a function, so we set it equal to 0. This one is an equation. Now, this one is already an equation. That's not a name equation. So we can solve this one. Now, how many variable types do we have? 2, right? When you have 2 variable types, you want to get everything on one side equal to 0. If you're going to be sketching a graph, you want to get everything on one side and set it equal to 0. Now, y'all go ahead and find the 2 points of intersection. There's Y1, there's Y2. I'm going to do it quietly over here. You can just hit clear to clear out your Y1. Too easy? You still working? What's that? You didn't get 1 and negative 2.5? You got to make sure you could type it in incorrectly. My nails are shorter than yours.
I didn't put the -5.
Oh, -5,
I
yeah.
had to add it before the 0.
Well, it's only equal to 0 because you brought the 5 across.
Wait.
And where the 5 was, there is now a vacant. See, a 0. Does that make sense?
No, I'm confused. I'm sorry.
Well, what if I had you add 2 to both sides? You would put +2 over here and +2 over
So I
there.
wouldn't add
We're
5.
we're
I just.
subtracting 5 from both sides.
Oh, okay. I see what you
Yeah,
So I
yeah.
didn't subtract it from anything. I just
You
added it to the. I know
you
what
just
you
got
mean.
rid of it. Yeah, that's a good way to look at it too. I'm glad you said you got it. Okay. What's nice about this is we can verify these by factoring, because that does factor into 2x plus 5x minus 1, and the roots of that are 1 and -5/2, which is what we got.
Does it matter like which X goes first?
No. When you find them, you can find them whichever one it gives you first if you want. When you list them, I don't care if they're in increasing or decreasing order, unless, of course, you're doing an interval notation where it has to be in increasing order. You can write it however you'd like. Okay. All right. So that's 2 of them by graphing. All right. So those are the keystrokes. Questions on that? Y'all got it? All right. Well, let's move on to solving by taking square roots. We'll do square roots and factoring, and that'll be it for today. We'll stop at the quadratic formula. Now, I have my own instructions for this as well, right? So this is going to be for what I call extracting square roots. You do this when you have, this is when you have one variable type, like an x squared or an x, okay? You isolate the variable. That means get it on one side and get everything else on the other. And then number 2, you're going to do take plus or minus the square root. That step should be easy. But don't forget to do plus or minus. Plus or minus. Okay? You want to try one out? I want to try one out. We'll go back to that. All right. So you take stock here, and you're like, I only see one variable type, right? Just an x squared. There's not an x squared and an x. It's just an x squared. So even though it's equal to 0, I don't want it equal to 0. I want it isolated. So that's x squared equals -48. And now you're like, okay, now I got the x squared isolated. Now I'm going to take the square root of both sides, and we need the plus or minus on the numeric side. So it'll be plus or minus the square root of -48. All right. Now the thing that we always do is we simplify. Always simplify if we can. So I'm noticing 2 things we can do. First of all, there's a negative under the radical, right? So we can just bring that out front and call that I, and then times the square root of +48. But 48 itself, while it's not a perfect square, it does have a perfect square factor. So remember, if you're not sure how to simplify a radical, you could do the upside down birthday cake. 48, 2 goes into it, 24, 2 goes in 12, 2 goes in 6, 2 goes in 3, 3 goes in 1, and then there's the flame. Yeah. So there's a pair of 2's, so one of them comes out. Here's another pair of 2's, so another one comes out, and we're left with a 3 that has to stay underneath there. And then you can just combine that and say 4 plus or minus 4i square root of 3. Oops. There we go. Extracting square roots. Just make sure you do the plus or minus. Otherwise, you're only finding half of the value.
So how would you find the intersection?
How would you find the intersection? Well, they're imaginary, right? That's a good question. If you looked at x squared plus 48, it would be 48 up here, and it opens up like this.
So there is no.
So there's no real solution. But because it's a quadratic, it can actually have two solutions. Gauss proved that. It was the fundamental theorem of algebra. So if they're not real solutions and it can have up to two, they must be imaginary. And in fact, they are. They're imaginary right there. Those are the two conjugate imaginary pairs. 0 plus that and 0 minus that. So I'm glad you said that. I probably should have pointed that out up above when we had the one. But this is good. This is good timing too. Okay. If you don't see any real solution, let's come back up here and just add it. 0 real solutions and 2 imaginary solutions. And then when it bounces, it is there twice. It's real. It's just a double. It's a double root. Okay. Let's try this one. 9x squared minus 12 equals 0. It's equal to 0 for us. That's kind of nice. That's kind of handy. But you know what? It's not what we want it to be. We want it to be x squared equals something. So I need to solve for x squared, which means we need to do PEMDAS in reverse. When you solve an equation for x, you are doing PEMDAS in reverse. And a lot of people don't realize that's just SADMEP. SADMEP. So what are we going to do first? We're going to do addition subtraction. We add 12 to both sides. That gives us 9x squared equals 12. And now what we're going to do? We're going to do addition or division and multiplication. That's going to be divide through by 9. You get x squared equals 12 ninths, which is, save it for another line, 4/3. And there you go. Now you have x squared equals 4/3. So you've done all the algebra to get x squared by itself. Now it's time to take the square root. And we do it on the numeric side, plus or minus. We do that first. It's like you look forward to plus or minus. It's the first thing you write. Yeah, all right, plus or minus. And then it's the square root of 4/3. Now, if this were a free response answer or a question on a test, you could stop right there. But if this were a multiple choice answer that I was writing, here's what I would do. I would put another version of it, because this is the same as the plus or minus the square root of 4 over the square root of 3. See how they're both under the radical, so they can both get the radical? And that is the same as, why would I do that? What is the numerator now? Square root of 4 is just 2. It's a perfect square. So there's another version of it. And I don't mind that version at all. And maybe that would be an answer choice. Maybe that's a multiple choice question.
What if you put like all of those just to trick us and one of the better? Is there
Which one's better?
like which one do you prefer?
I like this one here that we stopped at, or there's something else we could do. We can multiply by the square root of 3 over the square root of 3 and rationalize the denominator, and that gives us 2 square root of 3 over 3. And this is also okay. So I like this one and I like this one.
So those two are your favorites?
Those two are my favorites. Yeah. And if I had to pick between the two, I'd actually pick the one up at the top. Yeah, I just like it because it has fewer things in it, right? It has one less factor. And I don't mind radicals in the bottom. I think they're naturally in the bottom, right? They seem like they carry greater weight. Doesn't the top look like a little top heavy? Like if this thing was balancing on the 3, like it could topple over. Like the vinculum is basically like one of those balance boards. It's pretty precarious, right? But look what's happening in the one right above it. You got the square root of 3 standing fast, and he's got a flat head, and you put the balance board on his flat head, and he's wider and stouter. Anyway, that's why I prefer the first one to the second. Thank you for listening. I feel like I was doing like a book report at school or something. Yeah. Thank you. Um, all right, solving by factoring. This is so easy for us. This is how we've been solving, right? So we have f of x. This is on the next section, by the way. This is under factoring. Again, don't pay attention to those. I'm going to give you my own instructions. Actually, these might be good. Yeah, those are good. Set the function completely equal to 0. That's good. And then factor. Okay, so let's do that. We'll set it equal to 0. Once you set this equal to 0, now you're focused in on this right here, and you're not focused in on the f of x anymore. In fact, on a test or something, I would give you a check just for setting it equal to 0. That is that important to me, to see that equation. And now you have two variables, right? You have two variable types, so you're not going to isolate it. You're going to get everything on one side and set it equal to 0. You try to factor it. That's always your first step, because factoring is so much more efficient. And the first rule of factoring is to look for a common factor. And do you see a common factor there? You could do like this. You could put your hand over your eyes and look into it, and it helps sailors see farther. So if it helps you see farther, did it help Peyton? No? Okay. I don't see a common factor, but I wanted to. The 4 and the 12 looked good to me, but the x squared of the last didn't have anything. So we'll just go ahead and set it up. It's something, it's something times something equaling 0. And I know it's got to be an x and an x. And this is the easy one, right? We're looking for factors of 12 that add up to 4, or negative 12 that add up to negative 4. That's going to be some type of 6 and 2, right? 6 and 2 looks like they got it working out. And let's see, 6 is the larger number, and it's got to be negative. And the plus 2 is positive 2 to make the product negative. There you go. Now, from here, we split them up, and we say x minus 6 equals 0, or x plus 2 equals 0. And then from there, we solve, and we get x equals 6, or x equals negative 2. I would be delighted if you went from this step to this step here. That is, if you could skip the step in between. Okay? Notice that it's the opposite. Yes, it's the opposite, because when we say what are the solutions, we're looking for the value of x that when we plug it in makes it true. So when you see x minus 6, plugging in a 6 for x gives you 6 minus 6, which is 0. And that's why it's the solution. Some people just say, I just remember it's the opposite. And I'm like, way to go for the full concept there, Buster. Way to go. You're getting the right answer, but do you really understand why? Nope, I'm just saying it's the opposite. Don't care if you get me the right answer. Right answer. That sounds like an old timer. What's he doing taking algebra 2? Maybe he never graduated high school and he wants to. Who's to argue with a man like that? Who lived through the Great Depression, the Dust Bowl years? That's too easy. I'm just talking right now because we're done. That's the answer, right? How easy is that? Now, make sure, like on a free response, that you keep it equal to 0 all the way down. It has to be an equation all the way down. If you leave the equal sign off one time, you're going to get dinged. Get dinged. I say that when I ding people on papers. Ding! Everyone at home says, another missed point, huh? And I'm like, you darn tootin'. And the dogs think that they're getting a treat every time I say ding, because they think it sounds like food. I don't know. Dogs think everything sounds like food. You be 2 rooms away and you're just like a little wrapper just crumbles a certain way. And shut up, golly! Like, why? It's not. Why do you do that? She is so needy. But we made vows, and until death do us part, I guess. I'm stuck with her. All right. How many variable types do we have? X squared and x. That I count is 2. So we're not going to isolate anything, are we? No. Instead, we get everything on one side equal to 0. Now, for me, naturally, I like a leading term that has a positive coefficient. I love that. So being x squared, the leading power, the leading coefficient then is 2, and it's already positive. So even though it seems like more work, I would elect to bring the two things on the right over to the left. I would call that 2x squared plus 7x minus 4, and now there's nothing over there. A few people last period brought the 2x over to the right because they said it's only moving one term, and that's fine. It seems like less work, but then you got to flip both sides because you got the 0 on the left now, and you got to multiply through by -1. And by the way, don't fret if you did that and you get negative 2x squared minus 7x plus 4 equals 0, and you're like, oh, Mr. Corpy likes positive leading coefficients for a reason. I'm just going to multiply this by -1 and multiply this by -1, and guess what you get? You get that right there. Okay, so if you find yourself with a negative leading coefficient and it's equal to 0, just on the line below, just go through and change all the signs. It's fine. All right, now, nothing is common, right? There's no common factor. The 7 is ruining it now. But we know that it factors into something times something equals 0. And here's what's cool. The 2, which is the leading coefficient, it's prime. So it has to be a 2x and a 1x, or a 1x and a 2x, depending on how you write it. Now, 4 can be a bit tricky because 4 has two different ways to factor. It could be a 4-1 combo or a 1-4 combo, or it could be the old 2-2 combo. Well, the 2-2 combo, if you try it out, is going to give you like some type of 4, or see, a 4 and a 2, which gives you a 6 and a 2, which is not what we want. So it's got to be a 4-1 combo. And to get enough magnitude to get up to a 7, I'm going to put the 4 in the back so that it multiplies with the 2 to give me the 8. Now I'm too big, so I need to subtract the 1 that goes there. And the 8 is the positive term because, or the 4 is the positive term because the 8 is the positive up above. And this has to be negative. And we just factored it by guessing and checking and using context clues. No? FOIL it out. Does it work? I think so. I hope so. X minus 1. So if you're needing help with factoring, right, we've already covered that this year, I'd be happy to help y'all in the morning. I did learn another method from Mr. Healy, the way he learned it when he was in school. It's called like the shuffle and shake method or something. I can teach that to you if you still struggle with this, because it seems like it's okay. It seems like it works. But anyway, we factor. Now, once we factor, we could try to skip the step, and you could do that with x plus 4. If x plus 4 is the factor, what's the corresponding root or solution? X equals what? -4, right? But the 2x minus 1 might throw some people for a loop. So if you want to go ahead and still say 2x minus 1 equals 0, or x plus 4 equals 0, you could do that. And then you get x equals -4. But over here, you get 2x equals 1, which means x equals a half. And there's your two solutions. Right? So once you get the product equal to 0, then you set both of them equal to 0. And yeah, you can flip it closed because that's all I was going to do today. Any comments or questions? Comments are always welcomed as well. Like, boy, howdy, that was an invigorating lesson. Oh, nice. Boy, howdy is it's an interjection. It's a way to express like pleasant surprise, like wow, like boy, howdy, I didn't know fish could swim. Right? Anyway, try using it. Peyton's already used it once today. Everyone else try using it and sprinkle it into your conversations. Boy, howdy. It's an exclamation.